All right. Welcome to our second edition in our series of webinars where we explain how generative AI can have an impact on your business. I'm saying second edition because just 2 weeks ago, we actually had another webinar on the topic where we approached it a bit more from a bird's eye view, if you will. And now, but if you didn't see that webinar yet, then we highly recommend you to also have a look at that webinar, which you can easily find on our website. Just go to www.element61.be, go to webinars, and under recorded webinars, you will find the first webinar will be this webinar. But don't do that just yet, because it's no prerequisite to have seen the other webinar to be able to follow this webinar. Do it just after listening to this webinar and you'll be just fine. Because before taking off in this webinar, we'll actually do a very quick summary about the other webinar, and we'll just take it from there. All right, so the other reason why I'm saying it's a series of webinars is because we actually decided to split the deep dive webinar into two different webinars, into two parts, if you will. So this week we will mainly tackle the backend side of the story, while 2 weeks from now we're actually focused a bit more on the front end. All right, so who am I? My name is Johan Vergouwen. I'm an analytics architect at element61. I'm actually also the co-host of the Generative AI Belgium meetup group. So
Is the sound back now? It should be okay. All right.
all right. Okay, I'll recap. Oh, there's a molecule. I'll recap from the start of this slide.
Yeah.
All right. Okay. So as I started mentioning exactly, we're in this webinar, we're going to focus on the back-end side of the story. So the goal is that you can walk away from this webinar in, let's say, an hour, understanding an hour from now, understanding the following things. So first of all, how are we actually going to connect your private knowledge base to a generative AI solution? So we're going to talk about things like knowledge base embeddings and storing those embeddings in vector stores, but also how we're going to do all of those things and which components we're going to end up choosing. Then secondly, we're also going to talk about, let's say, the big kid on the block, the LLM, or the large language models. You hear all about them lately, and we're going to show you, like, okay, is the choice of your LLM really that important, or might there be other factors that are maybe more important to your decision? And then lastly, we're also going to talk about something that will glue it all together, if you will, because will have those individual components, but somehow you need to make everything work, right? And we're also going to talk about that, like how are we going to glue everything together? And so, of course, at the end, we're going to end up with a small conclusion. That's Q&A. So if you have any questions, then will be the time to ask those. All right. Then just before we get started, three very small practical things. So first of all, if you have any questions, feel free to ask them either in the chat or in the Q&A section. And if they are really long questions, you can just ask them at the end. And at the end, there will be a Q&A where either Peter, myself, or Lewis will answer your questions. Secondly, if you think like, oh, this slide is really interesting or whatever, there's really no need to take like a screenshot of that slide because you will actually get the webinar afterwards. You will be able to review it and you will also get access to these slides. So there's no need to do any of that. And then thirdly, if you have any connection issues or if there are sound issues like we already saw now, if they're really like big issues, you can mention them to us. If there are smaller like connection type of issues, please try to like disconnect and reconnect, and usually the problem will be solved. All right. So without further ado, I'm sorry, I'll leave the word to you, Peter, for a small introduction to element61.
Yeah, thank you very much, Johan. And indeed, it will be a very brief introduction. I think if I look at the names that are on the list, most of the people that are in the webinar already know us. So who are we as a company? We are a consultancy firm. We were 120 people. Last Monday, we had a couple of new joiners, so we reached the number of 120 as of Monday, or 2 weeks ago, actually. Active in the world of data analytics. So in a very broad sense, any question that a customer might have around data and analytics is something that we can help you with, whether it's in business intelligence, whether it's in performance management or data science related. We have the expertise and the team to help you out in this domain. Of course, a session of today is mainly around generative AI, OpenAI, and everything that is revolving around this. Which is part of the data science team. Know that that is only a subsection of what AI can do. What we typically like to do with customers is deliver impactful AI solutions, and the generative AI part is one thing, but of course there are many other things that we can do together with our customers. So if you have any questions around that, of course, feel free to reach out to us as we will be able to help you out as well. And with that, I think I conclude my very short introduction of element61, and let's dive deeper into the topic of today, the generative AI like an F1 car. That triggers already my interest.
All right, Peter, thank you so much. So exactly, on the first slide, you've seen an F1 car, and probably up until now, you've been thinking like, why the heck was there an F1 car on the first slide, right? And that's actually because we believe that there's a very big similarity between having your first generative AI solution and starting a new F1 team. And allow me to explain you what the similarities are. So first of all, it goes really fast. New models and new techniques are being developed every day and every night. So while you're asleep or while you're awake, new models are being developed. It's really fast. Secondly, there's also this big question about which model do you want to use to power your generative AI journey? Are you going to develop your own engine, or are you going to use an engine that's been tested and approved? So, and if so, which one are you actually going to use? And then thirdly, it seems so complex. It seems really complex because sometimes it feels like you need to be a prompt engineer to be able to drive these things, to be able to use your generative AI model. Next issue, your data might look different from my data. So how do we accommodate for that? How do we accommodate for the different tracks that we're actually riding with our generative AI solution? And then lastly, in the field of we're in the field of study where small differences can have a huge impact. What if your generative AI solution, or what if one of your colleagues is working with a generative AI solution and the model has a small error, has a small mistake in the answer? Those small errors might have very big impacts. So you will see that throughout this webinar, there will be very striking similarities actually between F1 and generative AI. And of course, we won't shy away from showing you those. All right. Also, I promised you guys that I would start off with a very short recap, and now is the moment that we are going to do so. But the recap, it's going to be a short recap. That's why it's a short recap on the slide. So please buckle up, fasten your seatbelts, and enjoy the recap with me. So first of all, in our previous webinar, we talked about this concept called an LLM, or a large language model. We explained that those large language models actually are situated on the barrier between NLP, or natural language processing, and deep learning. And while the main focus of NLP is understanding, interpreting, and generating human language, large language models is taking that generation or generative component really to the next level. So by being trained on vast amounts of data, they're actually able to to take input and generate a response based on that input. And then secondly, so the second big stream of our previous webinar was about your data. So we looked at your data and we saw that it needs to be converted to a certain data type, which we called the document type, in order to be able to work with it. This is basically some text with metadata, so very simple. But as computers do not really understand text, we need to translate those into something that a computer will understand, something with numbers, and we call those vectors. Once we have all of those vectors, of course, we're not going to throw them around randomly, so we need somewhere to store them, and that's going to be our vector store. So that was basically the second stream of our previous webinar. And then finally, we showed you guys the high-level overview of how our chatbot will work. So we covered the private knowledge base, the embedding, and the vector database. And in practice, a user will then come up with a question in the chat interface, and that question will be embedded and will also be added to the prompt and sent to our vector database. After the vector database has found documents that are relevant to answer that question, these documents will be added to your prompt. This whole concept, by the way, is called a retrieval concept, or more specifically, a RAG concept, or retrieval augmented generation. And then lastly, the question and the relevant documents are then fed to your LLM, which will then send the answer or generate an answer for you and send it to you. Don't worry if this overview is, or if this slide is a bit complex. If you watch the other webinar, it will all make sense how this very high-level overview looks like. But now let's have a look, or let's have a deep dive rather, at the backend. Okay, so we want to start building our model, but we're going to need some raw materials or data, if you will, to build that model. But where are we going to get that data from? And what are we going to do with it? Let's have a deeper look at it right now. So first of all, where does the data come from? In the previous webinar, we already discussed this, but let's go over it a bit more in detail here. In essence, there are probably three main sources that you're considering right now. First of all, you might have like a SharePoint or a Confluence type of location where you have some files that you want to use. Files that reside here might be, for example, PDFs, Word, video, and so on, those kind of files. Secondly, there's also a data lake, which is for most of our clients actually already their bread and butter nowadays. Typical files that you find here can be like CSVs, Delta files, and so on. And then thirdly, you have typically like a SQL database where you can have tables, views, you name it. Okay, now what I want you to do is I want you to imagine your data lake as like a very big manufacturing site. Because we want to make our F1 car, it's going to be our big manufacturing site where we're actually going to bring all or almost all of our raw data together. Because we've arrived at a stage where most of our clients already have their data on displays typically, and it's typically like structured and semi-structured data. But your data lake is actually a place where you can store any type of data very cheaply. And so what we believe is that today is a day that you also want to start putting unstructured data on there as well and reap the real benefits of generative AI. So in essence, what we're going to do is we're going to copy data from the SharePoint and put it on the data lake using a component called Azure Data Factory. The SQL servers for the SQL server, sorry, we can just keep it like that and keep it on the SQL server. All right. So we know which data we want to use and we know where it's located. Now it's time to start thinking about like how are we going to feed that into a generative AI setup. And because we have data from all kinds of data types, we need to have a way to read in that data efficiently. Enter document loaders. What a document loader is going to do is it's going to essentially read a certain file type and put it in the so-called document file type. And the file type of the document type is actually nothing more than a piece of text with some metadata. So very simple. It's important to note, though, that every file type will require a specific document loader in order for us to be able to retrieve the data. So let's say that you have a PDF, a CSV, and a Delta file, then we will need a PDF loader for the PDF files, a CSV loader for the CSV files, and so on and so forth.
Maybe a question on that end. Every document type needs a different loader. Are there loaders for every document type that there are in the world, or that we can imagine?
That's a good question, actually. So what we do is we work on those ourselves. So there are definitely document loaders out there, but part of it is also like things that we need to develop ourselves. But maybe it's a good question for you, Louis, to elaborate a bit on.
Yeah, we are going to talk later about LangChain, which is a framework to use these document loaders, and they have support for more than 50 document types.
Okay.
It's open source, so if there is one that is not supported, you can plug it in and develop it yourself for the entire community to reuse it later.
Okay. So it's actually a component that we can reuse and should not build ourselves unless we have a very exotic dots, whatever file type.
Exactly. If it's very exotic, you need to do it yourself. But like say for 99% of the times, they're really irrelevant.
Yeah. Okay. Thanks.
All right. So you can already imagine, like Peter is already asking questions here, you can already imagine that there are going to be some challenges here. And so first of all, we're going to have to create or use a different document loader for every different file format. And so, for example, while CSV, PDF, and Word will probably cover about 90% of your bases, as we just discussed, you might also want to have some exotic files, like some exotic audio or image or video files. What about those? Might be that you need to create something yourself. Also, so sorry, I just mentioned, so if you have some exotic files, then you need to do it yourself. But next, we also want to stay up to date, right? So what if a file gets updated? Let's say today you upload files, but tomorrow or next year, those files are deprecated and you have a new version. You need to have a way to upload new or delete old or whatever, update your file base. So we should prevent, in essence, that our chatbot gives answers to questions based on information that is not correct anymore or deprecated. The last thing, of course, we want to have is that our model is running on all the tires. So sometimes we need to have a fast bit stop to make sure that we're running on the latest data. And then thirdly, we also want to stay on top of innovations. And that's also an important one. Because I just explained that we currently actually copy all of the data from the SharePoint to our data lake. But the goal is that in the long term, we will be able to directly connect to the SharePoint. But while this connection is currently still in preview and we're not really fond or convinced yet of its performance, we currently still opt for the copying situation where we retrieve it from the data lake later.
maybe two questions on that. So first of all, you mentioned exotic data types such as images or video, JPEGs, PNGs, MP3, MP4 files. Are they really exotic? I mean, or how should I consider this?
Do you take that question or do I take Lewis?
I don't think they're exotic. There are really document loaders for image videos.
Okay.
But it's more difficult to process because they don't contain text.
So in a way, the document loader first needs to translate, for example, the image and text, which then is loaded as a text document. In essence, that's what's happening.
And then converted to embeddings.
Okay.
Yeah.
Okay, cool. So exotic doesn't actually exist anymore. And the second question I received this week from a customer is, I have lots of files and they're not on SharePoint, but they're in a certain application. So they're, for example, in Showpad, I have lots of files. Should I then get first extracts out of that application and then send it to Data Lake, or how could I handle that? Do you have any insights on that?
Do you have an insight, or should I take this one?
Take it.
So I think it's a very specific case. So I think one thing that would especially work is indeed if you have exports and you can set up like some automated pipeline that just puts it on your data lake. I think that would be like the least brain effort type of solution, but it would definitely work, I think. And then secondly, you could also think like, okay, are they working on, so like from Microsoft side or whatever, are they working on like a direct connection towards the software that I'm using? If that's the case, and if it's already not in preview anymore, if it's already in production, then you can maybe make it work that way. So I think it's very specific on what software it is, and if it's easy to set up like an automated pipeline for it. But as long as you can do something like that, there's always a solution to either put it on your data lake and retrieve it from there, I guess.
And then a final question we also receive quite often, and I saw it just popping up in the chat as well. How do we manage access rights of documents? So we have SharePoint with folders. I have access to folder 1, 2, and 3. You have access to folder 1. Mm-hmm. How do we manage that? Is this something that is being developed today, or?
Yeah. So basically, when you move it to Data Lake, you need to add metadata about who has access to what. And then in the backend of the application, you have to take that into account to filter out which documents you don't have access to. So when the LLM generates the text, it will be injected into the context of the prompt, only what you have access to.
So today in copying, you need to add it yourself. I can imagine, and it will probably be the case, that Microsoft is kind of copying the access rights from SharePoint, or will be able to manage that or solve that going forward. I can imagine.
Yeah, probably that will be in the direct connection. Another thing I want to add though as well is one thing you can do is if you have, for example, a certain chatbot, you can also have like different variations of that one. You could say like, okay, this specific agent is going to be used for those people. We'll talk in a certain way to those people, and we'll also only have access to this specific data. While, for example, another variant that you might have a different style of conversation. Well, it's not needed, of course, but might also have access to different data. So that's also like, if you cannot filter it at the source, you might have even other opportunities to do it further down the stream.
Okay, so in essence, it's not a problem.
Yeah, it's not really a problem.
Perfect.
All right. Okay, so where are we now? Maybe small recap. We just explained you guys how and where we are going to get our data and how to load it in. And so you might be wondering, like, okay, we have now like this document loader, and we put it in a document format, and you might be thinking like, okay, is this now actually, do we have enough to start interacting with our LLM, right? We want to get started. And unfortunately, the question there is not quite, because it is true that our data is in a standardized format, but it's still not in a format that a computer will actually understand. Because in order to do that, we need to make sure that we translate it into something that a computer does understand. And how we do that is by use of embeddings. So let's jump into that right now. So yeah, we're going to do that right now. So let's recap what we actually want to do. What we need to do is we need to transform our documents into something that a computer will understand. And if a computer understands it, it means that we can somehow like fit it into a model, right? But unfortunately, computers do not understand our language. They only understand the language of numbers, right? So we need to kind of translate every word in our document to a big series of numbers. That's what we're essentially going to do. So to give you a flavor of what this is doing, let's translate a simple sentence, hello world, with 5 different embedding models. And so you can see that for each of these models, we will end up with a very large vector of numbers, so like an array or a list of numbers, if you will. But if you look closely, you might notice that the different numbers in those arrays are actually different. And even the lengths, which is like in brackets at the end, and even the lengths of those vectors might differ. And so while explaining you guys like how and why these differences exist is very interesting. We're actually going to focus on one key thing that is maybe more important than that, and that's like figuring out which model we want to use in terms of convenience, performance, and cost. Because let's be honest, that's why we're here. And in order to make that decision, we need to be aware of the fact that there's actually 2 types of models out there. The first ones are being the open source models. These models are models for which the code or the source code is freely available, but you need to host them yourself. And on the other side of the spectrum, we have the so-called proprietary models, for which you don't know how the code looks like, but you also don't need to worry about hosting. And so what are the pros and the cons of each of those? Let's start with performance. While by now it's unequivocally accepted that open source models tend to slightly outperform, well, no, I'll say it differently. By now it's actually accepted that open source models tend to outperform proprietary models slightly. To back this statement, there's actually a wildly popular benchmark by Hugging Face, which scores about 100, it's a bit less, I think it's 78 different models based on retrieval and other kind of exercises. And on this retrieval specifically, the entire top 10 of models is actually all filled by open source models. However, in practice, we haven't really had a case yet where we really needed to go open source with our embedding model. Secondly, let's have a look at the cost, right? So I told you that open source models are free, but are they really? This is where it gets really tricky, because you see, while the open or like while the source code might be free, you still need to be able to host those models somewhere, for which you're going to pay, of course. And at the same time, while proprietary models are not free, the price you pay includes the hosting. So what do we choose in the end? In the end, we chose actually for a proprietary model because of mainly the convenience and also the cost, to be fair. And so the model we chose, is actually the ADA model. And if you can play the, yeah. So the model we chose is the ADA model from OpenAI. And there are actually a couple of reasons for this. First of all, the model is very easy to set up. As you can see while I'm talking, it only takes a few clicks and the model is actually deployed. So it's very, very easy. Secondly, on the Hugging Face benchmark that I talked about, this model is actually the best performing proprietary model. So we're quite confident that it will hold strong in most use cases. And then thirdly, the performance of a model is also can be very use case specific. So while the argument may stand that one embedding model might be better in certain use cases than another one, it's usually very hard to know upfront which embedding model will perform best. So in other words, what we are actually saying is get your feet wet, get your hands dirty, get into the game as fast as possible, and only pivot from your initial solution if it's actually needed, right?
But so I hear you talk a lot about performance and how it actually is generally a very good model. You also mentioned cost in the beginning. What should I keep into mind of having a cost of embedding a certain amount of documents? Do we have better insights on that?
Yeah, I'm glad you asked. So for OpenAI, the cost is per 1,000 tokens.
Okay.
Just to give an example, if you embed 1 million pages, it will be like $50.
1 million pages, $50.
Yeah.
Okay. So that's already quite a lot of pages.
Yeah, that's really cheap.
In a way, that price is quite reasonable.
Yeah.
And does this mean that every time I want to update my embeddings, I need to pay the €50, or how does that work? Because you mentioned new documents, changes in documents.
Exactly.
Do we always need to pay this, or
after you embed them, the documents, you only need to embed if there are modifications or new files.
Okay.
So you don't need to index everything or embed everything. So it's gonna be a very small cost, just incremental charges.
Okay, so if I have 1 million pages and I change 10 pages, I pay tenth of 1 million of €50, which is almost negligible. Okay. So in a way, your startup cost is probably high because you start with nothing and you need to embed everything. But once you have things embedded, your maintenance cost of updating and deleting is quite.
That's correct.
Okay. Cool.
All right. So that concludes it for the embedding models already. So once again, where are we now, right? So we just discussed, I think, in my opinion, the most difficult part, which is the mathematics things where we do the embeddings. But now we still need to have a place where we want to store those embeddings. So let's have a look at how we're going to do that with our vector stores. So once again, it's time to introduce the vector stores, which is arguably, together with the embedding, actually going to be the most important component in our setup. Okay, so once again, short recap. What did we do up until here, right? We have our files, and these will be loaded into documents and using embeddings, sorry. And those ones we will actually convert into vectors using our embeddings. Yeah, I said it wrongly. So we have our files, we will make documents from them with our document loaders, and then using our embeddings, we will make vectors from them. And these vectors are like our individual parts to our F1 car, if you will. But we need somewhere to store them, right? Enter vector stores. This is the place, and this is the place where we're going to store our large vectors. And it's actually going to give us some advantages, because first of all, we can optimize the vector store to be very efficient at storing these so-called high-dimensional embedding vectors. Secondly, when these vectors are stored in an efficient way, this allows us to do a concept or to perform a concept which is called vector search, which we also, by the way, covered in our previous webinar. We already covered this, so let's go about it a bit more quickly here. What it actually does, like this vector search, is it's going to take an input vector, for example, a question or a prompt that you have, assuming that it's been vectorized. And it will then check for other vectors in your vector store that are closest to this vector in an n-dimensional space that your embedded documents are spanning up. And I know that was quite a difficult sentence that I just spit out there, so let's maybe just explain it in layman terms. Let's say that your question is the orange dot that you're seeing, right? So you have embedded it, whatever, it's somewhere in the n-dimensional space, and it's the orange dot. The only thing that your vector store is going to do is it's going to check, okay, which other dots are actually closest to this dot, which will be the green dots. And then it will basically just spit out all of the green dots and tell you like, hey, these are the documents that are closely linked to your question. Probably you'll find the answer to your question here. So this entire process is called the retrieval process and will be very important later in this webinar.
So it's kind of like ping pong. You first convert the document into embedding through embeddings into vectors, and then we'll do the reverse process to actually retrieve back the original document.
Exactly. You need to somehow like translate everything so that a computer can understand it, and then translate it back so that you can understand it. That's the thing. Okay, and just like the choice basically of your embedding model, the choice of your vector database can also hugely impact or significantly impact your outcome. Like some car setups are better at running on certain racetracks than others. There are also different challenges when it comes to vector databases, of course. And some examples, I didn't list them all here, but some examples of vendors that will solve those solutions for you will be, for example, Pinecone, Azure Cognitive Search, Elasticsearch, and ChromaDB, just to name a couple. But let's cut to the chase here and come to the one that we actually chose or ended up using. After evaluating all those challenges, we actually chose for Azure Cognitive Search as our main solution. We also played a bit with Pinecone, for example, but we ended up like settling with Azure Cognitive Search. I remember that one of the challenges that we already like hinted in the very beginning of the webinar was that it's going to be like difficult when we have different files and different versions of those files, and we want to keep up to date. And what Azure Cognitive Search is actually going to do is it's going to have like an built-in, if you will, mechanism for us to use to do all of that for us. So we don't really have to reinvent the wheel and do all kinds of complexities to solve that issue. Also, it has native connections to various data sources. So we don't have to like reinvent those either. And then lastly, Azure Cognitive Search also comes with something that is called like skill sets. And these are like basic functionalities that help us working with our data assets.
So those skill sets, I know there's in Azure a lot to do around cognitive services that they provide, such as OCR, for example, or other services. Does this mean that we can use those skill sets or use those services in cognitive search? Should I read it like that?
Yeah, Microsoft developed already like 20 different skill sets that you can use to enrich your data.
Yeah.
So you can use skill sets for preparing or transforming text, but also for videos and for image.
And so here again, that point comes into play where we can already handle images, videos easily because those skill sets are made available by Microsoft.
Yeah, there is a skill set for image which can actually recognize the objects in the image and then put it in text. So then you can embed that text for easy search.
And maybe a last reason why I think cognitive search is probably our preferred vector database. It's natively embedded in Microsoft Azure environment. So in a way, knowing that we like to use components that are built and work together seamlessly, that's also one of the reasons why we prefer to have that with Microsoft, I guess.
Yes, and the fact that they have inserts, updates, and deletes.
Okay.
So when you use another vector DB like Pinecone, so they have an SDK, and then you need to develop the logic to insert, update, and delete.
Yeah.
With cognitive search, that's done automatically.
Okay.
It will detect if a file is deleted, so the relevant vectors will be deleted. The same for updates. So if you make any modification, you will see it in the demo.
Yeah. So more out of the box solution, which compromises all the challenges and handles all the challenges that we have seen. Great.
I like it a lot that you guys are like really into these vector stores and so on, but why don't we just like show a bit to the people like what it can do? So actually Lewis, our colleague, was kind enough for us to create a small demo for you guys where he shows like the power of the Azure Cognitive Search. So without further ado, maybe let's just show that to the people.
A brief introduction. So in the demo is only 10 minutes. We're going to talk about cognitive search and the main components of cognitive search. And what I just described, the updates and deletes. I apologize in advance if there is any background noise. That's the challenges of working from home with a 1 year here trying to sleep. So go for it.
All right.
Let's hope that the audio works. Let's check that. If it doesn't work, let us know and then we'll talk you through it live.
in data sources and no store. as them in the chat, and I hope you enjoy the rest of the presentation.
All right. Nice demo. I'm actually very happy that you're still alive after I hear you coughing like that. It's actually very nice to see indeed how the risk of having misinformation, if you have the right documents in there, is very limited. If every 5 minutes you delete and update those documents or those indexes, there's only a 5-minute window where there could be a potential risk of having kind of a misinformation or no information. So I think it's very nice to see how it then actually goes in the back, because that's always
A question I have there, can you also make sure that, for example, certain files are being refreshed more often than other files, for example? Let's say you have a bunch of files that are really critical, that they need to be always having the latest and greatest information, and while other files you're like, okay, on a daily basis or maybe even a weekly basis. And it's
so the data source is connected to a container.
Mm-hmm.
So all the files will be indexed or re-indexed
Okay.
every 5 minutes. You could have different data sources and different indexers with different updatables.
Yeah, exactly. Okay, interesting. All right, nice. So indeed, it was. We also had some small technical issues trying to speed up the video a bit, but I think that didn't change the fact that the demo really showed like the capabilities of being able to update, delete, and so on. So very nice demo, and thank you so much for making that one, Lewis. All right, so once again, very small recap. Where are we now? So we just discussed the vector database, and I think we did like the main important components like the embedding and the vector database. But obviously there's still one thing you guys are probably waiting for, and it's the one on the bottom right of the screen, which is the actual LLM, right? So let's dive into that one. It's also going to be our last big component for everyone who's needing to take a breather. We're almost there, and so we'll cover the LLM. It won't be as complex as you think it will be, so that's already a good one. So without further ado, let's jump right into it. Okay, so all right, the LLM. So yeah, it's exactly it's titled the LLM, your engine, and why we did that was because we often hear or we often like to compare ourselves the LLM or the large language model with the engine of our setup or the engine of our application, right? But does it really deserve that recognition? Let's dive into that. So to answer that question, let's first recapitulate what is actually the job of the LLM, right? So in essence, what the LLM is going to do is it's going to receive relevant information provided from the vector database and the prompt, and is then going to, based on that information, deliver an answer to the end user by basically predicting the next word or doing a predict the next word exercise. So therefore, it's actually really reliant on the garbage in, garbage out principle, right? So if the vector database is actually unable to retrieve relevant information based on the question, then the LLM will have a very hard time to give an answer to you. But let's put that in perspective, because now you're probably thinking, what about performance of the LLM? Or what if tomorrow Google makes a better LLM, for example? And we want to say, hold your horsepowers, because if you pick up the newspaper tomorrow, let's say tomorrow you open up the newspaper, and on the second page you see that the new LLM has been developed, hooray. And you're stressing out because you're using a different model, and you're thinking, oh, maybe the one that I'm using is old or it's deprecated, and I need to change to this new one. And in case you open up your newspaper and you see that article, we want you guys to think about this particular slide. And I made it very easy, so I think it will be easy to keep that slide in mind. Because what this slide is saying is that when the output of your chatbot is wrong, and believe me, sometimes it will only be due to interactions with the LLM in 20% of the cases. In other words, the other 80% of your application going wrong is actually due to the retrieval, so due to the embeddings and the vector database. So many people would think that the LLM is the engine, if you will, of the application we are building, but actually it is not. It's actually the vector database and the quality of your embeddings that is going to be doing the heavy lifting for you. But what does this mean? What it means is that when optimizing, let's say, your particular solution, let's say you have an application that is running and it's in production and you want to optimize it. When optimizing that solution, it's often more important to start looking at your embeddings and your vector databases rather than trying to switch out for the newest, like the latest and greatest LLM on the market. So that's the main takeaway that you need to get from here.
All right, kind of a big statement, no? I mean, I hear often we need to use GPT-4, for example, to give an example, because it's better, and and it shows that it's better. But in essence, what you're saying now is, if the case is not very specific or doesn't require a very specific or complex language model, do not bother and use 3.5, which is probably much cheaper.
And to say it to answer that with a very difficult saying, in Latin there's a thing, a pars pro toto, which means that you use one particular thing to basically summarize the entire market or to summarize the entire space. And what I believe is that like the choice of the LLM is representing the bigger choice where you have choice between open source and proprietary. Because if you remember, for our LLM, we had the choice between open source and proprietary, and we're going to come into that like in the slide that you're seeing right now. But also for the embeddings, we have the same discussion. So sometimes it's easier to just like say, okay, we have the open source versus proprietary discussion on the LLM model, but like, let's say the developers in the back of their mind, they know that it's a way bigger discussion than only the choice of the LLM. I don't know, do you want to add something to that, Louis, from your personal viewpoint?
Yeah, something to add there is basically the difference between using ChatGPT and your own private GPT. Like the one in the demo is that we are using RAG, Retrieval Augmented Generation, and it's basically we are injecting content, factual content into the prompt to be able to generate an answer. And in ChatGPT, we are just using the model itself. We don't use any real data, so what was trained on. So there is a big difference there.
So in essence, what you're saying is, in your own chatbots, the content is actually the golden nuggets of what you want to get out.
Yeah.
But the language model in itself is just language, like we are speaking now in English.
Yeah.
It knows English, so it can get the information out of the documents and rewrite it, rephrase it, so it's a proper answer. But the true value is actually your data. Once again, so it's the LLM is just kind of the last piece.
The LLMs are very good at writing text. But you have to be cautious. There have been some things in the news, like lawyers using ChatGPT to generate text for the judges, but doesn't really work out.
Okay, interesting.
Yeah, to iterate on that as well, it's like in any type of data science situation, the data itself will always be the cornerstone of your solution. So whether it be generative AI, whether it be like machine learning, we always will look first at your data and then secondly at the solution. So it's always going to apply that garbage in is going to be garbage out, and this is no.
And in this case, the data is the embeddings and the vector database.
Yeah, and the data that you supply to it. So make sure that you govern your data so that only the files that need to be fed into this thing are going into it, and not all the deprecated files. And as long as you got that going on. And by the way, there are even companies here in Belgium as well that are specializing on this particular thing, where they say, okay, and so it's really a big thing where they say, okay, this data throughput, we really need to make sure that it's optimized. So it's really something that lives in let's say the generative AI space, but also here in Belgium.
Yeah.
All right, I'm going to shortcut this slide a bit. I'm going to discuss it a bit more quickly than I anticipated because we're running out of time a bit. But you will see for these LLMs, basically the same concepts will apply for LLMs as they did for our embedded models. So you will see that open source models, especially in the long term, will probably have an edge on the proprietary models in terms of performance. But then in terms of cost, you again have this trade-off between having to pay either for your model or either having to pay for hosting. And then thirdly, but not leastly, there's also like a convenience factor where if you can just take an off-the-shelf model, for example, from Google or from Microsoft, you can just start using that model right away. So it's a bit easier and it gets you started quicker than if you would, let's say, choose for an open source model.
Yeah, maybe on that, because I see here on the slides, we have AWS, we have Google, Microsoft, Meta. I know Google has their BART model, Meta has their Llama model, Azure is partnering up with OpenAI. Does the choice of working in Azure have an impact on the LLMs we can choose? Because I can imagine that BART from Google and Azure from Microsoft doesn't really fit. Louis, how do you see that?
For in Azure, there is an integration with Hugging Face, so we can use any open source model.
Okay.
So on Hugging Face, you have some vendors, Google, for example, Amazon, they release open source models as well, so you can use those open source models in Azure. But BART and Titan, they are proprietary and they are not in Hugging Face. So those ones, you need to use their cloud.
Okay.
So that's a bit different.
So in essence, if we work in Azure and we want to use proprietary models, we're kind of needing to work with the OpenAI models, or potentially then Meta and Llama model.
Yeah.
Okay.
There are also from Databricks models, for example.
Okay. Also, one small thing I want to add in terms of those like open source versus proprietary is the exact cost, right? So let's say you have a model that you have an open source model and you want to, for example, run that on an Azure GPU. So you say like, okay, I'm going to host it myself. Then you count on like, let's say 10 to 20 euros that you will need to pay per hour to host that model. So that would translate to roughly, let's say 7,000 euros a month. To put that in perspective, if you use a model from Azure OpenAI, then you can already do, with GPT-3, for example, you can already do 250 million API calls in a month before you hit that 7,000 euro cost cap. So it's really a balancing act where you can say like, okay, will I have like that many API calls? Probably not. Then it's probably going to be handier if you're gonna use the proprietary model. If you're like a huge, let's say, multinational, and you're expecting people to be on there every day with huge amounts of people, huge amounts of API calls per person, yeah, then you might consider going for the open source case. But
or if you have a very specific case where an open source model is truly built for that particular need that is very specific and niche.
Exactly. Correct.
Cool.
All right. So then this, okay. So this was like maybe a bit of a reminder slide, but we already tackled it. So we chose for GPT-3. Now it's no surprise anymore. We already sold it multiple times. And so in essence, basically you need to remember that what your LLM is going to do, it's going to take in your question, it's going to get the information from the retrieval process from your vector search, and then it's just going to predict the next word. So that's basically what's happening there. All right, so this is going to be a very short one, and it's going to be about frameworks. And I promise by that one we will close the loop, literally, because it's going to be about the chain. And so what we need to do is we talked about all of these components, but somehow we need to like glue them all together, right? So how are we going to do that? How are we going to orchestrate or make everything work in tandem? And so instead of gluing things together, what we're going to do is actually chain them together. And the software or the framework that we're going to use for that, it's not really software, it's more of a framework, is called, believe it or not, LangChain. And so what you can see is all of the individual pieces of the chessboard that we've already been talking about today. You can see them all as like a colored chain in the chain that you're creating. So for example, you might have question summarization, prompt engineering, retrieval, your LLM, and so on. These will all be like small chains in your process. And then LangChain will be on the picture, the like golden chains that keep them all together. So they will be the LangChain will actually be the framework that makes sure that we are doing everything in the correct order and that everything is organized and so on and so forth. And then one other thing, you might be on the fence, and I've seen, by the way, on some of our meetups, that some people are on the fence and they say like, I don't really like using a framework. I can do it better on my own. It's better if I do it because I know what I want from my generative AI solution. And what I want to say is, while there might be people out there who might indeed have their own opinion about it, I would try to steer away from doing that, because let's say that a person in your company creates his or her own, let's call it, framework of way of working, and 2 years from now that person decides to leave the company. And what if, how are you going to maintain and further develop your code? What we advocate is try to make it as standardized as possible so that you can continue working on it, and so that there's also like a worldwide documentation and community around it. And that's why we chose a framework, and in essence, we chose for LangChain.
I think interesting one, because indeed, if we look at whatever is happening, LangChain is kind of the go-to framework. As you can see on the slide, we are also a LangChain partner, which is very interesting because we get kind of some updates on what is coming up. So that's very nice. There's one thing that I've been seeing in the last few weeks on LinkedIn, and mainly coming from Microsoft's sources. It's something called semantic kernel, and I understood that it's also a framework similar to LangChain. What is that semantic kernel?
It's similar, and they call it an AI orchestrator. So basically, it allows you to connect data sources to LLMs and to plugins. So the difference with LangChain is LangChain was released 1 year ago. So, and it's supported in Python and JavaScript. Semantic kernel is only a few months ago. It supports Python, Java, and C#. Microsoft, they claim that they use it as the core of the Copilot software that they are developing. So in theory, you could develop the same, but it's not moving as fast as LangChain does.
But it could very well be that semantic kernel then becomes kind of the de facto standard in the Microsoft space. So it could potentially be a good alternative for LangChain.
Yeah, it could be, but I have seen also some demos where they use semantic kernel and LangChain together.
Yeah, okay.
So it's not exclusive.
So we'll have to see how things evolve. I also understood that semantic kernel is still in preview, not even public preview, or?
Yes, in public preview.
Okay.
It's open. I don't know if it's open source.
So we'll have to see how things evolve there.
Yeah.
But okay, good to know. And in essence, so LangChain is then the go-to framework. Will be mentioned to semantic kernel. Are there other frameworks or?
The thing is, LangChain has it's open source, so there are a lot of contributors every day. Yeah. They release versions every day, literally every day. So, and in the GitHub community, you can ask questions, report bugs, and they will be solved in a few days. So you will have releases, bug fixes as fast as possible.
Okay. Nice.
Yeah, so once again, that stresses out the thing that we already said, like, are you going to choose for like a community where people work on it together and basically use their brains together, or are you going to develop something internally and so I think there the choice is quite easy to try to go for something that is more standardized, more people use it, so that it's also easier to attract new, let's say people to your company if you want that person to work on your generative AI solution.
Right.
All right, so that concludes it for today. It was quite a very packed and dense session, I think, with a lot of deep dives into different components. We're going to wrap up here, and we're going to have some like small advertisement for our next webinar, which is going to be in 2 weeks again, which will cover the front end of the story. So basically now, and you can actually skip this slide. Basically now, up until now, what we've done is we have created our F1 car. In essence, we have built our components, but we don't know how to drive it yet. So what we're going to do basically in our next webinar is we're going to hand over the steering wheel to you. And we're going to tell you like, okay, this is how you drive this thing. And even more so, if you go to the next one, even more so, we're even going to show you like how you can drive on different circuits, right? Because I told that my data can be different from your data. So how do we drive those setups? And we're also going to talk about that. So that's going to be our front-end deep dive. Normally, it's going to be a bit shorter than this one, and it's also going to be a bit easier to digest. So I wouldn't shy away from that.
Will we then also cover the concepts of fine-tuning, prompt engineering?
Exactly, that's what it's going to be about.
Okay.
Correct. Yeah.
Because indeed the context will depend. So you see two tracks. You have a street circuit. You have like a hilly circuit.
Exactly.
Depending on where you are, you change your prompts and you change your.
Exactly. And we will show like which different levels that you need. What do you need to think about first? If that doesn't work, you probably need to upscale to a different solution. Yeah. We'll talk all about that.
Right.
All right. So then, without further ado, it's time to finish up this session. So as the previous time, we want to do a quick shout out to ourselves actually, and to you guys as well. So first of all, thank you for being here. And the fact that you came here to probably the previous webinar and this one means that you know that the train is actually taking off, as we said in the previous one. But still, there are some trains in the stations. So I would say buy your ticket now. Assemble your F1 car if you don't want to go by train, and take a ride with us. And so if you can go to the next one, I think by having these sessions we try to both inform you guys what it is, because it's a very, very complex topic that we're running on right now. But also we want to show you guys that we have the expertise in house. We know what we're doing. We know the components we're working with, and we've really let's say analyzed which ones would be best in which use cases. So if you're planning on having like a generative AI solution and planning to work it out, we can easily build it out for you, have our demos working in basically 2 weeks, and you'll be ready to roll. And of course, from there, we need to check with you in terms of governance and so on, for which we will probably also have another shorter webinar in the future to tackle those kind of topics. All right, so that covers it. I don't know if there are questions still to answer.
There's actually a question in the chat, which is an interesting one. So the question is, we do not have a data warehouse yet. So there's ambitions and there's plans to build a data warehouse. Question is, what do you think about platforms like Dante AI to get started? I don't know if you know what Dante AI is, Luis.
So Dante AI is just a chatbot generator with your own data.
Yeah.
But you need to upload the files and your image and your videos. So maybe the difference is that with Azure, you have everything in your own cloud. You don't need to move it outside. So
in essence, I think what I show here on screen, in essence, what Dante AI is doing is bundling this in a SaaS platform, I guess, where you send your data to. And the chatbot is generated on your data, but you need to send your data to another service, which is then the Dante AI data lake. They do the embedding. They choose which embeddings they apply. They choose which vector database, and they choose kind of a prompt engineering. So in essence, it's probably a very quick setup to get started. However, know that you're giving away
your private data.
A lot of information, a lot of data, and a lot of control. Because we're now discussing, you have different tracks for different situations where you want to kind of tweak, fine-tune. You might want to change your skill sets in your cognitive search database based on the documents that you know best. In essence, if you work with a solution such as Dante AI, you can get started very quickly, but you lose that flexibility of changing things yourself. And I think it's something to consider. Similarly, as you can buy other platforms which are kind of SaaS alike, or you can build things yourself. It's a choice. No, in this case, that you give away all your documents to a third party, and they might put on their website, no, it's very secure and we'll manage it. But it could very well be that in a few months they kind of have a breach and your data is out there. So, and again, I'm not advocating against Dante AI. I can only encourage those kind of solutions, but just bear it in mind that if you want to be in control, and I think you want to be in control of all your data, it's probably more worthwhile to have something set up yourself, knowing that this backend, as you can see it here, can be used for multiple use cases. Right? So you can build kind of a chatbot on your website, embed it on your website. You can build an internal chatbot. You don't even need to use a chatbot, but just use the vector database to optimize certain processes. So it's kind of a workhorse that you can use for multiple use cases. And I think Dante AI is probably more one solution, the chatbot on your data, fully managed by the company. And so it provides some inflexibility which you need to be aware of. I think that's an essence.
So in summary, there's one thing I think really to highlight here: the difference with our solution, let's say, or most of the solutions, if you work on it yourselves, you keep having your own data. But if you basically it's an API call where you say, okay, this person had this question, and by the way, we found that these documents or these parts of documents are probably answers to that data. So let's say you have a document of 1,000 pages. You're only going to send one page, for example, to that API, and then it's going to retrieve the answer for you in the solution that we're discussing right now. So with the Dante AI, what you're actually going to do is you're just going to dump your entire files out there. So that's basically the decision you need to make. Do you want to have that extra security of keeping all of your data at your location, or are you okay with sending it to them?
All right. And then another question, Azure Cognitive Search can be quite expensive. Do you use alternatives?
I can take that one.
Yeah, go ahead.
So Azure Cognitive Search has tiers of pricing. So it has free, basic, standard, 1, 2, and 3. Basic is $50. Standard is $250. So it's not really expensive
per month.
Per month.
Yeah.
And with the limits are the amount of text you can process. So we made our test with the basic, for example, and if you want to index a file of 100 pages, the text is truncated at 65,000 characters. But with a standard S1, you can index up to 4 million characters of text. So that's like 1,000 PDF size. So if you go to S2 and S3, you can go higher in the limit, but S1 is probably the best. And if you compare it with Pinecone, in Pinecone you pay per index. So in cognitive search, you can have up to 50 different indexes with the same pricing. In Pinecone is $70 for every index.
So in essence, like everything in life, it depends. In essence, you need to look a little bit into your use case. What types of files do I have? Do I want to have the capacity of uploading big files or more indexes? And depending on that, you can choose an alternative. So either Pinecone or ChromaDB, which is an open source vector database, can be used as well. I think, and let's just be honest, indeed, it comes at a cost, right? So it's not free. However, you also should kind of build a business case around it, right? Building a chatbot just for the sake of building it is nice for R&D purposes, but the purpose of things that we're trying to do here, it's also optimizing, it's being more efficient, it's reducing time. And in that sense, imagine that you have just a very simple case, something that we see happening quite often, is putting all of your intranet files or HR documents on the chatbot, rather than people asking your HR person constantly the same question, because let's be honest, what types of questions pop up? I want to take holidays. What is my balance? Or I want to choose a new car. What is the procedure? Always asking those questions, it adds up to 5 minutes per question. If you just add it up, a cost of 250 euros a month is really not that expensive if you take into account the savings of time that those people are already having.
Take into account that in Pinecone or in the other vector DBs, you have to develop yourself the observes and the deletions. That's added cost.
So in essence, I think the answer is yes, it can be quite expensive. But as always, make yourself your business case, think about your use case. And indeed, if the pricing model of Azure Cognitive Search doesn't fit your specific case, then look at alternatives which have a different type of pricing, which might be better suited to reduce your costs. But as we also mentioned in the call, the vector database and the embeddings are kind of the centerpiece of everything. So do not cut costs on kind of the core of your solution, because otherwise you will end up with bad results. You might be cheaper, but it will be less good results. So I think that's kind of the summary then in that sense. Okay, I hope this answers your question. If you want to talk a little bit more about it or discuss, feel free to reach out. As you have already noticed, we like to talk, so we can always dive deeper into this. I don't see any other questions in the chat, so that means that we can conclude 4 minutes ahead of time. So that's very good timing on our side. We'll share the slides again, like last time, in the through a form on our website. You can download it there. The demo piece, we will put it, or we'll publish it as an insight on our website, so you can always rewatch it there as well. And then for the next webinar, I would suggest check our websites, and we will publish when the next session will be and how you can subscribe for that. And we will also post on all the channels, LinkedIn, X. I don't know if we publish up there, but mainly check LinkedIn and our website for the future webinars. Thank you very much for your attention. Thank you also, Johan, for the nice presentation, and Louis for the expert advice. And we hope to see you back in the next session. And if there's any questions, you can always reach out to us.
Thank you.
Bye.
Bye.